Okay, in this lesson we're going to learn how to sketch the graphs of the sine and the cosine functions. So we get the values for our graphs, our x and y values, from the unit circle. Now remember, it's the coordinates on the unit circle are x and y values, but each of these sets of coordinates is a cosine of that angle or a sine of that angle. So for instance, for 60 degrees, the cosine of 60 degrees is 1/2, and the sine of 60 degrees is square root of 3 over 2. So when we graph the sine and cosine function, we're using the angle in radians as our x value. That's going to be our x coordinate, and the sine or the cosine will be our y value. Let's see what that looks like. So if I'm graphing f of x equals sine x, x would be my angle, and y would be the sine of that angle. So let's look at just the basic for main angles. So if I have 0 or 360, or 0 or 2 pi, 0 or 2 pi radians, what would the sine of that angle be? Well, it would just be the y value at that angle, or 0. So the sine is 0. So at 0, the sine is 0. What about 90 degrees, or pi over 2 radians? Pi over 2 radians. Well, we go back to our unit circle. What is the sine of pi over 2? It's just the y value, which is 1. So the sine would be 1 at pi over 2. So if I filled in a chart with these angles, for instance, at 0, my sine is 0, but at pi over 2, my sine is 1. What about pi at pi radians? What is the value of sine at pi radians? Well, let's go to that angle. Well, the sine is 0. The cosine is -1. The sine is 0. So at pi radians, the sine is 0. Okay, the next key point. So the sine is 0. So it was 0 at 0 or 2 pi, 1 at pi over 2. At pi radians, the sine is 0. At 3 pi over 2, because remember this angle was 3 pi over 2 radians, what is the sine? Well, go down here, it's -1. So the sine is -1. So if we fill in the rest of our chart, or we keep filling in our chart, at 3 pi over 2, the sine is -1. And then back to 2 pi, the sine is 0 again. So it kind of goes in a pattern. If you can see, it's 0, and then it goes up to 1, then back to 0, down to -1, back to 0. That's one period of this sine function. If I were to graph it, notice when we set up the graph, we have a long x-axis and a short y-axis. We're not going to do negative angles for now. You'll do that in your next math course. So we're going to start at x equals 0, because that's the first angle on the unit circle, and we're going to end at x equals 2 pi. Notice I'm putting angles on the x-axis. Well, what other angles are in between there? Well, we've got 1, 2, 3 more angles. So let's divide that into equal parts. This would be pi, this would be pi over 2, and this would be 3 pi over 2. What about the y values? Well, it looks like the lowest y value is -1, the highest value is 1, so we're just going to go 1 and -1. Whoops, that's not negative. 1 and -1. Now when I graph this, I'm just going to plot those 5 points. So the first point is 0, 0. The second point is pi over 2, 1. So I put a point there. And then pi, 0. So that's back on the x-axis. And then 3 pi over 2, my y value is -1. And then at 2 pi, my y value is again 0. So if I connect those, and it's a curve, I just graph it like that. So you graph it kind of a curve like that. Okay, this isn't in your notes. This was just to kind of introduce you. So now we're going to go to filling in the notes. Look at this. Look at this. Looks like a wave. If I kept going, it wouldn't ever go higher than 1 or lower than -1. So it's just going to keep repeating as a wave. And if I went backwards, it would do the same thing. So basically, it's called a periodic function, because each period just keeps repeating. So let's put all that into some formal notes. So a sine curve is just a graph of the sine function. and you can identify it by its period and amplitude. And you've heard that word amplitude before when we talk about music. Music is waves. That's got an amplitude. So the amplitude is just the height of the curve, and the period is the length of the curve. So how long is this period? Well, this period starts at 0 and ends at 2 pi, so we call the length 2 pi, and the amplitude would be 1. In general, when we write a sine function, we write f of x equals a, some number a, which would tell us the height of our graph, sine bx, and b is going to help us find the period, the length of our function. So the amplitude of this function, if I notice, this is 4, this is 2, so that would be 3. The amplitude is 3. And then the period, well, let's see, 0, and this one looks like it's negative because it's going down first instead of up. Back to 0, and then back to 0 again. That gives me 1 period, and that's at pi. So the period of this function is pi. Now in general, if I look at the function, how do I determine the amplitude and period? From the graph, I can just look at it. But what if I just have the equation? Do I have to graph it every time? No. The amplitude is just the absolute value of that a value, because if a is negative, like this one would have been negative because you're going down first instead of up, we take the positive value of that because a height can't be negative. So a would be whatever, or the amplitude would be the positive value of whatever a is. And the period, notice this one has got 2 periods up to 2 pi. So whatever this number here is, we just divide 2 pi by that number and it gives us our period. So the period is 2 pi divided by that number b that's in front of your angle. X would be the angle that you're talking about. So x could be, in this one, 0. Looks like pi over 2. That's pi over 4, because half of pi over 2 would be pi over 4. And then that would be what? 3 pi over 4, and then pi. So if I were going to graph that, I would need those angles and the y values that go with those. So let's practice finding just the amplitude and period first, and then we'll talk about graphing. So the amplitude of the function is just this number a in the positive form. So the amplitude for this one is just 1/2. But what about the period? Remember, the period is 2 pi over b. So you just need this number here. Now if that number is nothing, if there's not a number there, of course we would use 1. So for instance, in this one, theta could be your, theta is your x, because we're measuring it in radians. Remember, theta represents radian measures. So in this case, b would be 1. If you look at number 2, a is 1, because there's no a there. So in this case, it's 2 pi over 3. So the period, since b equals 3, we're going to use 2 pi over 3. And I just want to point out, if your b is a fraction, like it is here and here, you're just going to use this trick. So let's say b is 5/6. 5/6. I'm not going to use one that you have. If you did 2 pi divided by 5/6 to find your period, just take this number, multiply it by 2, so 6 times 2 is 12, and put it back over the bottom number, that 5. So it would be 12 pi over 5. And if you need to, you would reduce it. So go ahead and stop the video, and then when you come back, we'll go over those answers. Let's go down. Okay, so number 2, the amplitude is, we already kind of talked about that. Number 2, the amplitude was 1, because it's the absolute value of 1. The period, b is 5, so the period, I'm just going to use period is 2 pi over 5, and I can't reduce that, so I just leave it. Number 3, a is 4, so the amplitude is 4, so the height of that is 4. The period is 2 pi. Remember, notice I have a pi there also, so 2 pi divided by 4/3 pi. Well, the pi's are going to cancel out. Multiply that 3 by the 3 on the bottom by the 2 on the top. That'd be 6 over 4, which reduces to 3/2. Okay, number 4. The amplitude is 3 over 2, so we just leave it. You don't have to make it a decimal. 3 over 2. Since B is 1, the period is just 2 pi. So 2 pi over 1 is 2 pi. Now I'm going to erase this, so if you didn't copy it all down, stop the video. Number 5, the amplitude is absolute value of negative 2, so it's just 2. And the period, B is 3 over 4, so 2 pi over 3/4. You multiply 4 times 2, you get 8 pi over 3. And then number 6, the amplitude is just pi. The period is 2 pi over 2, which is just pi. Okay, so now that we know how to find the amplitude and period, let's go on to graph the function. You have to know the amplitude and period in order to graph it. So the first thing you want to do is find the amplitude and period. So in this function here, the amplitude is just 2, a is 2, and b is 1/2. So the amplitude is 2, and b is going to be 2 pi, or period is 2 pi over 1/2, and that would just be 4 pi. After you find the amplitude and period, we want the maximum and minimum values. Well, that would come from your amplitude, right? If your amplitude is 2, the highest value is 2, what would the minimum be? It would just be the opposite of that, or negative 2. Now let's go back to that original example we started with, where we graphed just the regular sine function. To get this pattern here, for the sine, we always start at 0 and end at 0. And then the first one, if it's positive, goes up to your maximum. So 0, then maximum, and then back to 0, and then your minimum, and then 0. So every sine function is going to follow that same pattern. So if you know your maximum and minimum, you can get your y values pretty easily. So this would be 0. So in general, it would be 0, max, 0, min, 0. Now remember, on the x-axis we put the angles, and on the y-axis we use your max and your min. Now let's set up our table for this function. I'm going to add a new page. Y equals 2 sine 1/2 theta. The amplitude was 2. Period was 4 pi. And max is 2 and min is negative 2. So my x's, we'll come back to that. So in here I'm doing 0. In the y's I'm doing 0. And the max would be 2. If it were a negative function, you would go to negative 2 first. And then 0. That means if a is negative. The min is negative 2. And then back to 0. Now, how do I get the angles? That all comes from your period. Remember, when we graph the unit circle with a and b are both 1, then this would be 2 pi. We just use the 4 corners of the unit circle. But in this case, we need those angles if we have 4 pi for our period. 0, 4 pi. So basically, we're going 2 times around the unit circle for this one. So half of that, halfway around through one period, would be 2 pi, right? If I've gone halfway through this period of 4 pi, I've gone 2 pi radians. And then 1/4 of the way around would be half of whatever, if in this case half of 2 pi, which would just be pi. And then if I go 3/4 of the way around, I'm just going to take this number, whatever that is, multiply by 3, so it'll be 3 pi. So when I graph this should be fun. I'm going to mark my 2 and negative 2 on my y-axis, and then I'm going to start with 0 and end with 4 pi. And then I'm going to put these other 3 angles in between there. So halfway would be 2 pi, then that one would be pi, and that one would be 3 pi. And then you just graph your points. So 0, 0, pi, 2, back to 0, down to negative 2, and back to 0. And then just draw your curve the best you can. Okay, so usually when I teach this lesson in the class, we need one more example before you're ready to go on your own. So I'll start the next one with you. And then I'm going to have you do just one of these um, for practice. So let's do this one. If I want to get my amplitude and period, remember, you take A, absolute value of A, so amplitude is 2, and your period is 2 pi over 2, and it's pi. Okay, and then you need your max and min, so that would be 2 and negative 2, and you make your table. So the easy part, getting your pattern on the y side, 0 max, 0 min, 0, would be the same as the last one, 0, 2, 0, negative 2, 0. The trick is getting the angles. That's where kids kind of have a problem. So I always say start with 0, end with your period, and then you work your way back. Take half of that, and that's your middle angle. Well, half of pi is just pi over 2. And then take half of that, and that gives you this angle. Half of a half is a fourth, so pi over 4. And then whatever this is, multiply the top by 3. Just always whatever this is, multiply the top by 3. So this would be 3 pi over 4. And then the fun part, drawing the graph. 2, negative 2. And then 0, pi. Then draw your other 3 angles in. Pi over 2, pi over 4, and 3 pi over 4. Okay, and then draw your graph. 0, max, 0, min, 0. I know it's not really a perfect graph. It'll look fine. And that's all you do. Okay, so which one do I want you to do? Let's do number 9 and number 11. Number 9 and number 11. Turn off the video, do those 2 problems, and then come back and I'll do them with you. Okay, so number 9, my amplitude is 1/2. Period, since B is 1, it'd be 2 pi over 1, which is just 2 pi. So this one is going to be basically the unit circle. The max is 1/2, the minimum is negative 1/2, and this is a positive 1, so we just keep everything in order for our y values. And then 0 and 2 pi. Since our period is the whole circle, this one's pretty easy because you just take your 4 corners. Half of 2 pi is pi, half of that is pi over 2. Multiply the top by 3, it's 3 pi over 2. And then 1/2, negative 1/2, 0, 2 pi. This is pi. This is pi over 2. And this is 3 pi over 2. And then draw your points. 0, max, 0, min, 0. And draw your graph. Okay, and then what if you have a negative graph, like number 11? Well, remember that amplitude is just going to be positive. So positive, it's negative, A is negative 1, so this will be the absolute value of negative 1, which is 1. And the period, since B is 1, is 2 pi. So really, the only thing that changed is the y column. The x column are the same as the one we just did. 0, pi over 2, pi, 3 pi over 2, and 2 pi. But this one, now since it's negative, our first one is still 0, but our next y value is going to be the negative value, the minimum. 0 min, 0 max, 0. So when you graph it, you just need to remember to go below the y-axis first instead of above. Pi over 2 and 3 pi over 2. Okay, and then to graph your points, you have 0, and then go to your min, then 0, then max, then 0. So it just look like that. Okay, and then the cosine function is almost exactly the same as the sine function, only now if I were graphing these points, I'm now going to the x values for each of those points. So in my y column, these would not be the same. You would have the x value, which is 1, and then 0, -1, 0, 1. So instead of 0, max, 0, min, 0, it starts at max and ends at max. So we would have in this column, let's reset this whole page. This column, you would have 1, 0, -1, 0, 1. So basically max, 0, min, 0, max. So everything else works the same. You just switch the pattern for cosine. I think I left it all filled in for this page. So yeah, so if you're looking at this example, y equals 3 cosine pi over 2 pi. The amplitude is 3, period is 4. The pi's drop out on that one. And the max and min are 3 and -3. And your pattern, max, 0, min, 0, max. And if that was if a is negative, then it would be min, 0, max, 0, min. And then, so let's try one. I'll go ahead and do this first one. So the amplitude is 1/2. The period is 2 pi over 2, which is pi. So my max is 1/2, my min is -1/2. So I start at 1/2, 0, -1/2, 0, 1/2. And then 0 and pi, and then just work your way back. Half of pi goes in the middle, so that'd be pi over 2. And then half of a half is a fourth. Multiply the top by 3, and you get 3 pi over 4. Now to draw the graph is going to look almost the same. This part's the same, 1/2 and -1/2. And then this is pi. This is 0, pi over 2, pi over 4, and 3 pi over 2. And then draw in your points. So now I'm going up here first, down, and then up. So the points are, the graph is going to look a little bit different. It's still, if you kept going forever and ever, it would still be a wave. It's just shifted over, obviously, because instead of 0 being your first point, y value, 1/2 is your first y value. So I'm going to have you try number 3. And that's it, number 3. Turn off the video, do number 3, and then come back. Y equals cosine theta. So for y equals cosine theta, the amplitude is 1. The period, since b is 1, is going to be 2 pi. So the max and min are 1 and -1. So 1, 0, -1, 0, 1. And then we go to 0 and 2 pi. We've already done this one several times, so this would be pi, pi over 2, and 3 pi over 2. So graphing that, 0, 2 pi, this is pi over 2. It's not pi over 2. It's pi. This is pi over 2. And this would be 3 pi over 2. And then we start at the max, go to 0, go to min, 0, max. And that's how the cosine function looks. Okay, so you've got a worksheet. I wrote on the assignment which ones I want you to do. Go ahead and work through those, and then check your answers, and we'll go on to the last part of this unit.